All right, so on A, what can I do here?
Cosecant is 1 over sine.
All right, so we have 1 over sine of theta, and then it's over sine of theta?
Yep.
Well, what are we going to do?
Well, you cross them out, huh?
You can't cross them out because you got a fraction within a fraction, but what can we do? Keep it, change it, flip it. So that means since that bottom one's going to flip, I need to make it into a fraction. So put it over 1. So we're going to keep it, so 1 over sine. Change it, so times, flip it. It was sine over 1, so now it's going to be 1 over sine. And I stress that because I see a lot of y'all forget to flip it when you actually do this.
There's be one side. How is that?
All right, so when we multiply fractions, we multiply straight across, right?
Yeah.
So 1 times 1 is
1
over, and sine times sine is
sine squared.
sine squared.
Never mind.
But wait, what is 1 over sine?
Cosecant.
Cosecant, so what is 1 over sine squared?
Cosecant squared.
So we get cosecant squared.
Perfect.
All right, on B, what can we do?
Make cosecants 1 over sine.
All right, both of them or just one of them?
Make both of them. Both of them.
All right, so we have sine, oops, forgot my x, minus,
We can't cancel out because of a minus sign. They're connected.
y'all say cosecant is 1 over sine?
Let's multiply it by 1 over sine.
So you're saying go ahead and do keep it, change it, flip it?
Nah.
Oh, okay, I see what you're saying, I think. Are you saying that we can get rid of that denominator by multiplying it times it?
Yes.
And what we do to 1, we do to all, right? Okay, I hadn't thought about that way. So when I do that, then,
So it's just
what is sine times sine?
sine squared.
Minus, what's 1 over sine times sine?
Sine of 1.
Our signs cancel, so we get 1 over, on the bottom there, the denominator, 1 over sine times sine is 1. So we could say we have sine squared minus 1, correct? Can I do anything else with that?
No.
Probably, or she wouldn't be asking, right?
Oh, well, you never know. You never know.
All right, so what did I say earlier about when we have a trig function squared and a 1?
We can make it into something.
Look at your Pythagorean theorems, okay? And the one that has sine squared in it says, what is it, cosine squared
Plus sine squared equals 1.
plus sine squared equals 1. Well, let's see if we can algebraically manipulate this where I have sine squared and 1 on the same side. I want sine squared to be positive. Okay?
Say that again?
I want to get my sine squared and 1 on the same side.
You don't have opposite sides.
And they are on opposite sides right now. I want them on the same side, and I want sine to be positive. So, sine is positive where it's at, so let's move the 1 over.
Okay.
So we have cosine squared
Oh, you want the mouse.
plus sine squared minus 1 equals 0, right? But I don't want what on the same side as the others? Cosine, so let's move it over. So it's positive, so let's subtract it. So when I do this, I get what sine squared minus 1 equals negative cosine squared of x. Now, before we say that, yes, go ahead and put it in, make sure, is this the same exact thing we had in the problem? Are these exactly the same? Yeah, 'cause sometimes we'll have like sine squared and it'll be plus 1 on one and minus 1 on the other. And that's not exact, so that means we can't do it. But these are exactly the same. So what is sine squared of x minus 1 equal to?
Negative cosine squared.
Negative cosine squared of x.
Okay.
And you can't get any smaller than 1 term, so that's our answer.